Hey everyone, it's Jesse Stormer. I want to tell you a little bit about Ruby's internal I/O buffers. It might sound like a horribly mundane topic, but I've been spending a lot of time looking at it lately for my new book, and I find it pretty interesting. And I know there's some ways that it can affect the code you're writing. So let's have a look. Let's start by just creating a file to work with here in the home directory, and I'm just going to watch anything that's written to that file. So now in IRB, if I get a handle on that file, open the foo file for writing, and if I try and write something to it, notice that the write succeeded. It told me how many bytes are written, but there was no update to the file. If I try it again, same thing. Now if I flush the file, then I see it all come out at once, written to disk. So this is a function of Ruby's internal I/O buffers. Calling IO.write doesn't actually talk to the kernel. All it does is put things into Ruby's internal I/O buffer, and then flushes out that buffer, puts into the kernel's buffer, and lets it take over from there. So let's look at a couple other ways we can interact with this. So again, I can write, it doesn't show up down here, but for instance, if I write it 10,000 times, it did show up down here this time, without me having to flush. And this is because Ruby's internal I/O buffers are actually stored in memory. So if you put a lot of data into there and fill them up, they get auto-flushed for you, so they don't just take up more and more memory. And you do have some control over this behavior. You have the sync property on I/O objects in Ruby. So by default, on file handles, sync is false. So here again, I ask for sync, it's false. I can set sync to true. And when I do that, if I now just write a short string again, you can see it showed up in the file immediately. And again, and again. So when sync is true, this means that the I/O will skip Ruby's internal I/O buffering, and any calls like this will go straight down to the kernel. So again, if I turn sync off, then again I have to flush it manually. And one more thing, I've got sync set to false right now, so it should be using Ruby's internal I/O buffers. But if I use syswrite instead of write, I see it immediately show up here in the file. So the only difference between syswrite and write is that syswrite will skip Ruby's internal I/O buffers and go straight to the kernel. So just to bring this full circle, let's look inside Rubinius for a few minutes and see how it's implemented. Okay, so here we are inside the Rubinius source tree. Let's look at the kernel common IO file, and you can see this is defines the IO class, and the way that Rubinius works is it'll actually define this class in a few places during its loading process, and this class is actually full of Ruby code that's defining important IO methods. So here we actually have the write method on IOs, which is what gets called, what we're seeing in IRB when we call write on a file. This is the method that gets called. So you pass it some data, and Rubinius does some initial checks, and then it gets to this part. It says, if sync is true, then do a prim write with the same data. And prim write actually just sends the data down to Rubinius's C++ VM, and which talks to the kernel directly. But if sync is not true, which is the default when you're working with files, then it talks to this iBuffer. So it finds out how many bytes to write. While there's bytes to write, it unshifts those bytes into the iBuffer, and says here if the iBuffer is full, then it empties it. So what is this iBuffer? This is actually the internal buffer we were talking about. So in Rubinius, it's just a regular Ruby object that you can shift stuff into, and it gets emptied out when it's full. And it's actually defined right up here inside the same class, inside the same file rather. And you can see, for instance, we were just looking at empty2. So when the buffer is full, this one gets called, which again uses prim write to send the data down to the C++ VM, which talks to the kernel. So back at the console, If we actually switch to Rubinius and use it to open the file, open the foo file. I don't know if you remember, but inside the Rubinius source, it was saying that the internal buffer is stored as an instance variable called iBuffer. So we can actually get a handle on that. So here we go. IO internal buffer. You can see that its total size, or this is how much it'll take, up to 1024 bytes. Right now it's got 0 used. So if we take that IO and write something to it, and then inspect the iBuffer again, you can see now it's used 6 bytes, which is how much was written here. And again, we've still got the file going down here, and it still hasn't shown anything. But now we can actually manually flush. We can manually empty this iBuffer to the IO, which is what happens internally when the buffer is full. And we saw the data show up down here in the file. So that's roughly how it's working internally. One thing to note is that although files have sync, although sync is false by default when working with files, it's true by default when working with sockets. So if we start a quick netcat listener down here, which is just going to print anything it gets over a TCP connection, and then we make a new TCP socket connecting to that. If I check this IO has sync set to true by default. And if I write something to it, you can see it goes through immediately, no waiting. Now I could set sync to false and emulate the behavior that we're having with files. So I have to call flush in order to flush the data out all at one time. But by default, it's going to be true. And back to files for a minute. So this file, if I try to write something, right now it's stuck in Ruby's internal buffers, right? We're not seeing it on the disk, and there's no auto flushing that happens based on time passing. So I could leave my computer running overnight, and that buffer wouldn't be flushed. Now I can flush it manually, as we've seen. There's other ways that it'll be flushed for us. So if I close my handle on an IO, there you can see that it was automatically flushed for me. If I open it again, so if I write something, it's in the buffer. If I try to read from the same IO, you can see that the buffer was flushed before it tried to read, and then tried to read, and it wasn't able to get anything from the file, but the buffer was flushed before I tried to read. There's actually a few places that this happens. So if we take a look back at kernel comment IO in Rubinius and look at the write method, or sorry, if we go to the top and just search for anybody doing a flush, there's some documentation. There's where the method's defined. It just empties the iBuffer. You can see here in fsync, first it flushes the internal buffers, then it calls the fsync system call, which manually flushes the kernel buffers to ensure that your stuff goes all the way down to disk. Where else? If you change the position of the IO, then it'll flush the internal buffers for you. If you try and reopen the IO to point at a different one, it'll flush the buffers for you. If you try and seek, what else? If you try and do some kind of a read operation, it's going to flush the buffers for you. Or if you try to close, it's going to flush the buffers for you. So I hope you learned something about Ruby's internal IO buffering and how it might be affecting you if you're working with files, and how it's probably not affecting you if you're working with sockets. If you'd like to know more about Ruby's IO and working with sockets especially, check out my new book, Working with TCP Sockets. Thanks.